Today we are discussing the most critical aspect of our job, preventing blast furnace breakage or any damage to the furnaces. So inside that hearth we are managing hot metal at temperature upward of 1550 degrees centigrade. This is not just about the production, it is about the structural integrity. So this playbook serves as your diagnostic guide to identify early warning sign and your emergency manual. So coming to the longevity in a furnace is a not a matter of a joke or it's a luck. It's a matter of a systematic monitoring. It's a matter of a systematic discipline, workmanship. On one hand, we see Japanese furnace operating safely for more than 25 years through the rigorous engineering. On the other hand, we have seen catastrophes where a heart burned through under 3 years due to a blind spot in data. Remember, breakage is a gradual process of lining erosion. Your primary job is to catch the hot metal as it approaches the step coolers before it turns into an invisible sudden disaster. Coming to the our anatomy of the threat, that is the elephant foot. To prevent a such damage, you must understand the elephant foot, a garlic shaped cavity that forms at the hearth weakest point, typically 1 2 meter above the uh, tap hole center line. And this happens because the fast tapping speed accelerate the ring circulation of the hot metal, which actively creating a problem around the corner of the refractory. So maintaining a proper salamander depth is crucial as it helps solidify protecting layers and reduce the stress of that bottom circulation. So coming to the our hidden intruders like lead and zinc. So we always have chemical enemies in the body. We know zinc create a pan pot effect. It penetrate the brick lining and expand, which can actually lift the furnace shell by 150 to 160 mm and destroy the bottom seal. Lead is the cooling killer. It's a heavy, sinks below the hot metal and accumulate around cooling pipes, causing deformation and thermal breakage. We must strictly adhere to the maximum allowable limit in the burden, that is 0.15 kg per ton of hot metal for both combined. So this is one of the very important information that we must have to stick every aspects of the blast furnace. So coming to the step cooler thermal boundary. So think of the step cooler as your shield and water flow as your primary defense. A, a breach typically occurs at the seams between two step coolers where cooling intensity is lowest. If water flow is insufficient or blocked, the hot metal remains fluid and penetrate these gaps, burning through the shell. Our goal is to maintain enough cooling intensity to solidify that permeable iron before it ever reaches the boundary. So we must have to look into all those precautionary measures. Coming to the operator's radar, that is identifying the surge. So you most important breakthrough or your most important tool is the water temperature difference graph. Under normal operation, heat flux is steady. However, look at this warning curve. When you see a spike in the heat flux intensity, specifically exceeding 1500 kilocal per meter square or local erosion is becoming severe. Here is the critical rule. If the water temperature difference rises at a rate of 1 degree centigrade every 1 minute, a structural failure is imminent. So you must begin evacuation immediately. Coming to our diagnostic matrix, as you can see, the furnace state, this matrix helps you to categorize the furnace health. In normal operation, keep the foundation dry and maintain tapping speed. In a warning state, you will see smoke from the crack and rising heat flux. This is the time to shift the pressure and monitor closely. If you hit the critical state, characterized by white smoke, shell deformation, and that 1 degree centigrade per minute rise, you must stop everything and execute the code red protocol. And what is that code red protocol that we'll discuss later on. Coming to the daily deliverables regarding the proactive defenses. So prevention happens every shift through the three action. First is tapping speed control. Do not tap too fast or you will uh, create a elephant foot erosion. Second, fettling operations. We routinely add titanium to the body because titanium compound cells fail and patch eroded gaps in the heart. Finally, harmful elements tracking, that is the monitoring zinc and lead daily. If the breach limits, we must mandate alkali discharge operations immediately. Coming to our next slide, which is a very important one, and it's about the code red emergency protocol. So, if a breakage occurs, follow these five steps in order. 1. Evacuate and isolate. Clear all personnel and set a perimeter cordon. Number 2. Drop pressure. Immediately go out of blast or shift to bleeder. High blast pressure will act like a volcano, expelling hot metal. Third is clear groundwater paths. Ensure the foundation is dry. Water meeting hot metal causes catastrophic explosions. Number 4. Control tapping. If safe, continue tapping to lower the liquid level away from the breach. Number 5. Water management. Do not simply cut off stave water. Shift to low pressure flow to keep the stave body alive while we plan repairs.